plot between x1 and x2 with using the hue is equal to y, that is output variable. And I'm going to have the two different colors. One is red color and one is green color. Now, if I'm using this one, now here, how I'm going to separate the data? Now, for example, if you want to predict a new data point, this is the new data point. Now, for this new data point, whether it belongs to either red class or green class means in the KNN, what we have done is we have identified the nearest neighbors, and based on the nearest neighbor, we are classified that one, right? That is the one which we have worked for the KNN. Now comes to the SVM, how the SVM is going to work and how, for example, a new data point is there like this. Now it belongs to either red class or green class, how it is going to classify and what is the process it is going to follow. This one is going to follow miss. So here, first, whatever the data you have given, first it will identify what is the common pattern in that, and it will try to classify the data. For example, in this case, it is going to separate the data points by using a linear line, just by using a linear line. Now, what is meant by linear line? As I have told you in the linear regression itself, linear line means a straight line. Whether it is a horizontal line, whether it is a vertical line, whether it is a horizontal or whether it is a vertical or whether it is a slanted line, anything, either this one or this one or this one or anything, but it should have with respect to straight. It can't have the curvature like this, right? So which is having a straight line, then it is called as a linear line. Now by using a linear line, it is going to separate the data points. It is trying to separate the data points just by using a linear line. Now in this case, if you observe this scatter plot, it is going to draw a linear line and it is going to separate this one. Now linear line you can draw like this, you can even draw the like this, or you can even draw like this. So like this, how many types of lines are there? Miss infinite number of lines will be there. Like this, infinite number of lines options are there. Now, out of these infinite number of lines, which one is the best fit line for this data means, which is having the maximum margin, which can separate with a maximum margin. That is the best fit line. Where you can separate the data with a maximum margin is called as support vector classifier. Now, this maximum margin, this is the best fit line. A line which can classify the data with maximum margin is called as maximum margin line. And this is called as maximum margin classifier. And now this, from where the second part of the category starts, the starting point of the second category will be there, right? The starting point of the second category is called as support vectors. These two of them are called as support vectors. Based on these support vectors, it is classifying the data. From here, it is a different one. So this is called as a maximum margin classifier. This concept is called as maximum margin classifier, where it is going to classify the data points based on the maximum margin line. By using the maximum margin, it is separating the data points. So it is called as maximum margin classifier. Is that clear, guys? Now, so here you might have a questions. Not with respect, it is not completed. Don't worry, it is not completed. You might have multiple questions. Sir, here in this example, very simple data set you have selected, so you are able to separate. But you have taken a complex data set, how you are going to separate? Question number 1. If it is not separable by using a linear line, in that case, what you are going to do? That is question number 2. And what is meant by these support vectors? This might be a question. So like this, you might have multiple questions in your brain. So let us see one by one. Don't one by one. Let's start with so the concept is called as maximum margin classifier. Maximum margin classifier means what it is meaning is it is going to select a best fit line where it can separate the two classes with a maximum margin. Okay. Now, so this is called as a positive side and this is called as a negative side. And this is called as a line is called as a hyperplane. Why it is called as a hyperplane means since for example, I'm having a two-dimensional. In a two-dimensional, it is called as a line. Now, the same line, if I want in a three-dimensional, the same line, if I want as a three-dimensional, it is going to be as a plane, right? Where above some data points will be there, below some data points will be there. If you observe this one, For example, let us take like this, right? If you take some examples, okay. For example, you are taking some data points. Okay, some data points, assume that data points are in the 3-dimensional. Okay, some data points are in the 3-dimensional. Now this 3-dimensional you want to separate. You want to separate the 3-dimensional. How you are going to separate the data points in the 3-dimensional means by using some kind of a line. That line in the 3-dimension is called as a plane. So that is the reason it is considered as a hyperplane. Okay. Now how this hyperplane is selected means this hyperplane is working based on the maximum margin, where it is going to classify the two categories with maximum margin. Is that clear, guys? Now let us understand what is meant by these support vectors and how to identify those support vectors. Now here I'm having some apples and oranges. Okay, everyone knows apple means a pure red color, and which is of having some kind, and oranges will have the pure orange color. Now what's so special about SVMs means it is going to identify the support vectors. For example, these are the list of apples and these are the list of oranges. Now these are list of oranges comes under this category, list of apples comes under this category. There is no problem. Now support vector, it will be this one. Support vector means almost close to the orange only, but still it is not considered as an orange, it is considered as an apple. From which category the second stage starts? Okay, see, this is oranges, these are all oranges. I have given you multiple orange, which is orange colored apples, which are orange color oranges. Really they are oranges with orange color, and I have showed you some of the orange color apples also. Now you have to segregate them, you have to separate them. Now both of them by default the color is orange only. If you observe this example, here you are having the oranges, here you are having the orange apple. Now in this example, if you observe, out of these many apples, if you observe this one, these many apples, this apple only is separate one. These apples we can identify easily. Red apple, green apple, these things we can identify very easily. In the real life, where if you go to any apple shop means you can identify the red apples easily and you can classify them as an apple. You can easily taste that one. But something will be like this. You will also get a doubt that whether it is an orange or whether it is an apple. So the whichever the starting point of one class is there, that is considered as a support vector. This is the support vector of the apples. This is the support vector of the apples. Is that clear now? Support vector means clear. Now, so this is the support vector means from where the apples will be classified. Okay, this is the starting point. Now later we are having with respect to different. We are having with respect to pure, for example, this is there. Okay, this apple is there, or this apple is there, or this apple is there, this apple is there. No need to classify. Automatically everyone knows that one, right? For example, if you show it to a child, you have trained the child with a red color apple. Now next day, if you give this slight red color apple also, the child will not be identified, but because you have trained with a dark red color. Now this is a pure apple. Dark red color is a pure apple, assume. Okay. Now these are the light red colors. Okay, light red colors slowly. Now in order to convert to the red color, first the basically it is, see, in this red color it is mixed of red and light orange also is there. So some apples will be with respect to orange color. Now tell me whether it is an apple or orange means it is considered as an apple. Why you are considering still it is an apple? Because the shape is an apple shape, and whatever, if you touch that one or if you feel that one, inside that whatever the material will be related to apple. But the shape round color shape is there, the same round color shape is there, and whatever the above we are going to have the same thing we are having here also. Everything is same from here and here. If you observe, both are same, but there is a minute difference. That minute difference, if that difference also is not there, then it is classified as an orange. The minute difference from where you are going to have that, you feel that one as an apple from the starting point, you feel, right? That point is called as support vectors. Okay, is that clear? Now in the support vectors, Now we are having, these are the support vectors. Now within the support vectors, so using the support vectors, it is identifying the support vector of this class. It is identifying the support vector of this class. And after identifying the support vectors, it is going to make a line such a way that the distance between the support vectors, the maximum margin will be there. Sir, for example, let us take like this, the same example, whatever you have told. Now let us take example like this. Now in this case, what is the support vector? If this is the line, what is the support vector? This is the support vector and this is the support vector, which is almost close to the line. First, it will calculate the distance. Okay. Now after that, what it is going to do? It is going to try like this. Now this is the support vector and this is the distance. Now for the next line, now it is going to check the distance of this one and distance of this one. Now next this line, again distance of this one, distance of this one. Next this line, distance of this one and distance of this one. Now once it calculated the distances, once the distances are calculated, out of all the distances which is having the maximum margin, it is going to select that one. It is going to identify the maximum support vector which is having the maximum margin. So it is also called as maximum margin classifier. That is the reason it is called as maximum margin classifier. For every line, the support vectors will be different. For example, if I draw a line like this, automatically, if I draw a line like this, almost see, I'm drawing one more line. Let us observe this one. I'll draw a line like this also. But in this case, what happens? This margin is very high. This margin is very low. One side margin is very high. One side margin is very low. If I draw a line like this, in this case, one side the margin is very high. One side the margin is low. If I draw a line like this, one side the margin is very high. One side margin is very low. So I want to identify the distance between them. And I want to have the middle line, which can have the maximum support, means maximum distance, so that both of them will be classified properly. So that is the working of the support vector missions. Now, as I've told you what is meant by support vectors, now let us see the second one. If a data set is like this, same to same. Once again, I'm having the same x1 and x2, x1 and x2 and y. So for example, let us take one of the example of yesterday's data set, whatever we have worked on the yesterday's class, that is in the KNN. Yesterday's class in the KNN we have worked, right? Let us open that one. KNN, whatever we have done in the yesterday's class. So I'm just loading. Once again, I'm executing the code. So just I'm loading the data, and after loading the data, I'm opening the scatter plot. So here I'm having x1 and x2 and y variable. I'm just opening the scatter plot. Now, can you see the scatter plot? The initial scatter plot for the data set. Now for the SVM, I'm taking one more data set. This is a different data set. This is a different data set where I'm having X1 and X2 and Y. In this case also I'm having X1, X2 and Y. And if I apply the scatter plot for this one, and I'm having a scatter plot like this. This is a different data set where the scatter plot, initial scatter plot is like this. This is a different data set where the initial scatter plot is like this. So in this case, if you observe in this case, I can easily separate the data by using a linear line. I can easily separate the data by using a linear line, and where it can support the linear classifier. I can use the SVM, within the SVM linear classifier. Okay, which is nothing but maximum margin classifier. Now here, if you observe this one, in this case, for example, this is the data set was given and you have to apply SVM on this. How we are going to separate the data? Now in this case, if you draw a line like this, how you can separate? If you draw a line like this, how you can separate? In this case, how you can separate by a linear line? This is a non-linear separable. Okay, so here you can't separate the data by using a linear line. You can't separate the data. This data set is not supporting for that. Now in this case, what we have to do? Then we have to go with the non-linear SVMs. Linear SVMs are there, non-linear SVMs are there. Linear SVM is, it is going to use a linear line and it is going to separate the data which is having the maximum margin classifier. Now non-linear SVMs are also available. Now how the non-linear SVMs works, let us understand that. So here I'm having a data set in this way. Okay, I'm having a data set in this way where I'm having the red data points and green data points. Now if I'm using a linear line like this, it is not getting separated. If I'm using a linear line, no, it is no. If I write this, red data points are properly classified, but other side is not properly classified. One side is okay, but another side is completely error. Now in this case, what I have to do? If this is the data, the original data is set space like this, then in this case, what I have to do is, now because these data points are not linearly separable, we have to go with the non-linear separation. So if the data is linearly separable means you can use a linear line and you can separate. In this case, you have to go with the non-linear SVM. How we can know whether we have to explain a linear SVM or non-linear SVM is, first you can see the initial scatter plot. That is the first one. Second one, how to apply the non-linear means, just in the SVM, you have to select the non-linear. That is the hyperparameter. In the hyperparameter tuning, you have to go with the non-linear. Now in the non-linear, two options we are having. In non-linear, two options we are having. For example, let us take a one-dimensional. I'm having only one-dimensional. One-dimensional means this. Only X is there and directly output variable Y is there. Input variable, only one input variable is there. The one input variable, the values are, let us assume these values are something like this. 1, 2, 3, or let us take like this. 2, 3, 4. Let us take this one as 1. 2, 3, 4. And this one as in terms of 6, 7, 8, 9, 10, 11. Means my original data set consists of 1, 2, sorry, not 1. My original data set consists of 2, 3, 4, 6, 7, 8, 9, 10, 11. Total 9 records are there. Output of this one is red color. Output of this one is red. Output of this one is red. And green, 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 and red, red, red. I'm having a data set in this way. This is the data set. I'm having only one input variable and one output variable. If I apply the scatter plot, what this is the scatter plot, right? This is the scatter plot. Is that accepted, everyone? This is the original data. Raw data is only this one. For this raw data, you want to classify. You have to classify. Now, for 14, what is the answer? That is the question. For 14, whether it is a green color or red color is the question. Now, after see 2, 3, 4, after that again green, again red, maybe again green you may get, or again red only you may get. Who knows? So, for example, this is the data set. This is the data set where I'm having only one input variable and one output variable. And if I apply the scatter plot, this is the scatter plot. Now I have to separate the data. How I can separate? Now, if I draw a line like this, I can't separate. I can draw only a single line. I can't draw multiple lines. A single line. Using a single line only, you have to separate the data. Whether 100% accuracy or 90% accuracy or 98% accuracy or 60% accuracy, but only one line only you can draw. Now, here what I'm going to do is, I'm going to create a new column. I'm going to create a new column. Whatever the original column I'm having X, the X I'm going to keep as it is, and I'm going to create a new column in such a way that the new column is X minus 5 whole square. X minus 5 whole square. First, I'm going to do the X minus 5. Now, X minus 5 means minus 3, minus 2, minus 1, plus 1, plus 2, plus 3, next plus 4, plus 5, plus 6, right? Whole square. This first I have to do X minus 5. This is X minus 5 column. Now, if I draw this for every data point, I'm doing the minus 5, X minus 5. Now, can you see this? It was separated. It is separated. Now, if you are making a plot between this one versus this one, these two, forget about the original data. You are making a plot between this one versus this one, that is minus 3, minus 2, minus 1, which is in red color. And next one is plus 1, plus 2, plus 3. Plus 1, plus 2, plus 3, 4, 5, 6. Minus 3, red color. Minus 2, red color. Minus 1, red color. Plus 1, green. Plus 2, green. Plus 3, green. Plus 4, red. Plus 5, red. Plus 6, red. Is that satisfied? Now, original data was not there. This data is not there. Now, X minus 5 versus output. Is that clear up to here? Now, I'm going to create a column called as X minus 5 whole square. I'm going to create a column called as X minus whole square. Now, minus 3 whole square is 9. I'm going to have the 9, 4, 1, 1, 4, 9, 16, 25, 36. And I'm going to make a plot between X minus 5 whole square versus X minus 5. And I'm going to make a plot like this. Now, just observe this plot. Is that here? Up to here, it is okay. This is minus 3. This is minus 3. This is plus 9. This is minus 2. This is plus 4. This is minus 1. This is plus 1. Plus 1, 1. And plus 2, 4. Plus 3, 9. Plus 4, 16. Plus 5, 25. 6, 36. Is that okay? Scatter plot is okay. Now, what is the scatter plot I have drawn between? What are the variables? Between X minus 5 versus X minus 5 whole square, I have drawn the scatter plot. The scatter plot is between X minus 5 and X minus 5 whole square. The original data is X, created data is X minus 5, and one more data is X minus 5 whole square. This is the two created data. Now, I'm making a scatter plot between these two versus output variable. I have created a scatter plot between these two versus output variable. Now, can I, by using a linear line, can I separate the data points? By using a linear line, can I separate the data points? Now, similarly, is that clear, guys? So, now what happened in this example? If you observe clearly in this example, so please write in the notes this example clearly. Okay, question was given is to first raw data, right? Raw data. Data was given like this, raw data. The raw data is having X and output variable, that is 2, 3, 4. Next you are having is 6, 7, 8, 9, 10, 11. Red, 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 green, 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 red, red, red. This is the raw data. Write in the notes raw data first. For this raw data, can you draw the scatter plot, please? For this raw data, scatter plot. Draw the scatter plot. What is meant by scatter plot? Taking x and y and filling the values. So here x value is 2. What is the y value corresponding? Y value is nothing. So just I'm taking this one, 1, 2. This is the 2. And it should be red data point. So I'm keeping as red. Next 3, 4, 5, 6, 7, 8, 9, 10, 11, 1. Out of in the given question, 1 is not there. In the given question, 1 is not there and 5 is also not there. Remaining data points are there, out of which these 3 of them are red color data points. And this one also red color data points. And in between these 3 of them are green color data points. Green. This is the scatter plot for the given data. Up to here it is okay. Since there is no y variable, with no y, how I can draw a point here? If I want to keep a point in this here means with x also I will require the y value, but y value is not there. So y value is 0. So I'm having only one-dimensional data. Basically, they have given me only one-dimensional data. I'm having basically one-dimensional data only with me. I'm not even having two-dimensional data also. Not even 2 columns are there in my data set. I'm having only 1 column in the input variable. Now, this one, what I'm going to do, I'm going to convert. This one I'm going to convert in such a way that whatever the x is there, okay, that is original data set, your x, that is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is the original x and your output variable of red, 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 green, 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 red, red, red. This is the right. This is the original data set directly. Now you are going to transform the data. Do you remember in the polynomial regression what we have done? Can you anyone tell me what is the polynomial regression? Polynomial regression means just increasing the degree. So basically they have given a degree of normal, 1 degree, normal degree. Now what we have done, that is TV, radio, newspaper. If you are having like this, what we have done, we have taken the TV square. We have created a new column. After creating new column, what we have done, we have applied linear regression only. Created a new column with higher degree and applying the linear regression. Similarly, here also same. First, you are converting to higher degree and applying the linear classifier. Is called as nonlinear SVM. Simple. Increase to higher degree and do that. Now I want to increase to higher degree. Now higher degree, how I'm going to increase to higher degree means I'm going to identify how these 2 data points can be separated. That I'm going to identify the pattern. That is from where I can separate these data points means x minus 5. Before to x minus 5, everything is negative. After to x minus 5 is everything is positive. So why here I'm going to do like this means these red data points and green data points separate here. Now I want a maximum margin between these two. Tell me maximum margin I want means what is the point I have to select? What is the middle point? 5 only, right? 5 is the middle point. By using that 5, I'm separating the red and green with the maximum. For example, it is 6.5 is there. Then what I will do? 4 plus 6.5 divided by 2, which is nothing but 10.5 divided by 2, 5.25. So I will take the x minus 5.25 and I will separate. Since in the given data 6 is there, so I'm going to use the 4 plus 6 divided by 2 and that is nothing but 5. Using the 5, I'm separating the data points. So x minus 5 is the new column was created. And this is minus 3. This is x minus 5, minus 2, minus 1. And this one is 6 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6. And you are going to create a x minus 5 whole square. That is 9, 4, 1, 1, 4, 9, 16, 25, 36. Now you make a plot between these two. Draw the diagram in your notes. Draw the diagram for these 2 points. How you will draw? By considering these two, whatever you have created, x minus 5 versus x minus 5 whole square. Draw the scatter plot. How you are going to draw the scatter plot? Your scatter plot will be like this only, right? So for example, now for this diagram is going to be, scatter plot will be like this, where minus 3 comma 9. Minus 3 is here, 9 is somewhere here. Assume this is 9. First dot I'm going to keep here. Followed by, this dot should be red color, green color, red color dot. Why red color dot? Because the output variable is red. Next, second data point, minus 2 comma 4. Minus 2 is this one, 4 somewhere, 4 is here. This also should be red color. So I'm converting this one to red color. Next data point is minus 1 comma 1. This is also red color, red. Next 1 comma 1. Next one is plus 1 comma 1. Again this one. Now this time this is a green color data point. Here the output is green. So I'm writing green. Next 1 comma 4. 2 comma 4. Next 3 comma 9. Next 4 comma 16. 5 comma 25. 6 comma 36. Now I'm going to make these 3 of them as green color data points. This one, this one, this one green color. And this one, this one, this one as a red color. Okay, green and red are ready and scatter plot is ready. Now, once the scatter plot is ready, now you can separate a line. You can draw a straight line such a way that it is going to separate these data points like this. Can you draw a line? You can draw a line in this way. For example, if I want to draw a line, for example, let us assume this is only the diagram. Okay, for this diagram only I want to separate. Though it is a not a correct diagram also, still I want to separate. How I'm going to draw means, separated, right? Separated. So once I got the scatter plot, I'm going to identify that one, and at a certain angle, it is getting separated. Simple. So the original data is as it is, and using the original data only I have created everything. But these two columns are transformed columns, created columns. This is not the original data. These are created data. How? In the polynomial regression, we will create higher degree order, variable. We create the higher order variable and apply the linear regression. Similarly, here also in the poly SVM, we are going to create the same thing, higher order, and apply the linear classifier. That's it. Is that clear, guys? If you want, miss, I'll write in the notes very clearly. It is clear, miss, I will not write. Otherwise, no, sir, please write the notes, miss. Also, I will write as per your choice. Done? Online students. So this is one way where, so this nonlinear SVM works. The nonlinear SVM works by mapping to a higher dimension. Mapping to a higher dimension. In the notes, you can write like in, I mean, in previous step only, whatever I have told you earlier, that one only I'm writing clearly in the notes. Okay. So like in polynomial regression, like in polynomial regression, whatever we have done, that is, we increased the variable degree to higher. We have increased the variable degree to the higher level, and then applied linear regression over that. Like in polynomial regression, whatever we have done, okay, instead of using polynomial regression, whatever we have done is we increase the variable degree to higher level and then apply the linear regression. Okay. Now, what is meant by polynomial regression in shortcut? What is meant by polynomial regression? If someone asks you what is meant by polynomial regression, means increasing to higher degree, increasing the degree of variable, increasing the degree of the variable to higher level, and apply linear regression is called as polynomial regression in shortcut. This is the meaning of polynomial regression. If anyone asks in the interview, what is meant by polynomial regression, means increase the degree of the variable to higher level and apply the polynomial regression. The degree, to what degree I have to extend? Sir, we don't know the degree level, sir. We have to do the hyperparameter tuning. First, we'll try with degree of 2, degree of 3, degree of 4, like this. Which are the degree is best suited without having any kind of overfitting or underfitting problem? That is the best one. Similarly, here also same. Now, the same thing we are going to apply here. In nonlinear SVM, I'm going to write in the similar way. Non-linear SVM. In nonlinear SVM, we are going to increase the degree of variable. We are going to increase the degree of variable to higher level as it is. Whatever I have written in the above, here also I'm writing the same. And apply here also same. Instead of linear regression, what you have to apply? Linear classifier you have to apply. Okay. SVM linear classifier you have to apply. SVM linear classifier you have to apply. This is called as SVM nonlinear regression. SVM. This is called as nonlinear SVM. Okay. Within the nonlinear SVM, this is called as poly SVM. This is one of the SVM. Linear SVM, poly SVM. Okay. Is that clear, guys? Linear SVM is nothing but maximum margin classifier is called as linear SVM. Poly SVM is increasing to higher degree and applying the linear over that is called as poly SVM. Is that clear? Is that clear? Anyone, any questions? Now, next, sir, in this method, we'll work on the input data given only X value. It means single input as X1. Yes, whatever it is. For example, tell me polynomial regression is applied only on a single polynomial regression. Whatever we are having the polynomial regression. Whatever we are having the polynomial regression. In the polynomial regression, if I'm having one input variable X, that is some variable like, let us take something, your experience versus salary you are having. First, you are going to apply the linear regression. In the linear regression, it is not proper, miss. What you are going to do? You are going to apply the non-linear regression, that is polynomial regression you are going to apply. What you are going to do for that? Experience square, experience column, and along with the salary column. Now in this case, earlier it is a simple linear regression, that is beta naught plus beta 1 x. In this case, what is the equation? Y hat is equal to beta naught plus beta 1 x plus beta 2 x1 square only. You are having x1 only, but x1 square. Here x1 and y. Here x1 square. Now this is if you are having a single variable. If you are having two variables, if you are having three variables, in the example we have done so we are having the simple linear regression, simple non-linear regression. Similarly, multiple linear regression, multiple non-linear regression also, right? Multiple data is there means multiple, single is there means single. Now what is the difference between multiple versus single means? Only the input number of columns will be increased. That's it. Remaining everything is same. Is your question is clear? Non-linear regression is not only applied on a single variable. It can be applied even on the multiple variables also. In our case, polynomial regression we have applied on the TV, radio, newspaper completely. On three variables we have applied. We have not applied only on a single variable. Okay. But each variable, it will increase the degree. First, if you are having the TV, radio, newspaper, three of them are there. TV square you will get, radio square you will get, newspaper square you will get. Similarly, here also, if three variables are there, the first variable will be increased to higher degree, second variable also increased to higher degree, third variable also will be increased to higher degree. 10 variables are there, means 10 variables will be increased to higher degree. How many variables are there? Each variable will be increased to higher degree. And after increasing to higher degree, it will apply there the linear regression. First, it will increase the degree of 2, degree of 3, degree of 4, degree of 5. At any 1 degree, the linear SVM will work, right? At that time, it is going to use that one. So in the polynomial regression, how the degree, we don't know the degree, right? Degree directly for TV, radio, newspaper, you know that the degree of 2 will be the best one or degree of 3 will be the best one. You don't know, right? First, you have tried with the degree of range of 1 to 10. First, you have tried with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you have observed that after degree of 4, it is getting with respect to overfitting problem. Either degree of 2 or degree of 3 is a good one. And out of which degree of 3 is the best one. And you have concluded that particular algorithm in that way. Similarly, here also we are going to do the same. The same logic will be applied here. Just the degree, we are going to change the degree. At 1 degree, it is going to apply the linear SVM and it is going to separate the data. Right? Now, for example, I'm having a data like this. Now, what it is going to do means it is going to increase to the higher degree and it is going to apply the linear SVM. Directly here, you can't separate. But if once you increase to the higher degree, you can separate. Right? For example, if you see from here and you want to separate the moon means you can't draw a line like that. But if you go to the out of the space, easily you can separate. Between the planet to planet, between other planet to other planet also you can separate. Anything you want to separate means you can separate. Once you enter into the third, into the space. Now, if you want to separate, for example, by sitting here, can you explain how to separate the data points between two districts means? No. But if you see from the third from the top view, you can separate, right? If you see from the front view, you can't separate. But from the top view, you can identify there is some kind of thin line will be there, and based on that, you are going to separate. Right? Same to same. Now, this is one way where SVMs, what is the problem with the SVMs means either with the SVMs or polynomial regression, the higher the dimension, it is going to increase the higher dimensions. In the polynomial regression also same problem. That is the reason in real life polynomial regression will not be used generally. Though polynomial regression will give very good accuracy also, with respect to polynomial regression is having one disadvantage is called as in terms of higher dimension. It increases the more number of input variables. For small data sets, these things will be very good. Like if you are having 3 columns or 4 columns, these data sets are okay. For example, 50 columns are there means For 50 columns, if you increase the higher dimension of degree of 4 or 5 means you will get 280 columns. 280 to 350 columns you will get. So which is, it is going to take more amount of time to execute. Okay. If you increase to higher dimension, and after increasing to higher dimensions of 350 variables, and if you give the KNN means, KNN will take at least 4 to 5 days to give the answer. If you execute shift enter now, after 4 days, you have to see the answer. 4 days, your laptop should run only. If you say i5 with 8 GB RAM also, it has to run for 4 days. If you are having 350 columns and 10 lakh records are there, means literally your system will die. Right? So these type of algorithms, whatever the algorithms we are having, these are having with respect to base algorithms. These are all called as basic algorithms for small amount of data sets. Now, if you are having, for example, large amount of data sets, then we have to move on to the advanced algorithms that we are going to discuss in the tomorrow's class. Tomorrow's class is the advanced algorithms. Okay. So this SVM, what is the disadvantage with SVM is it is with respect to increase to higher dimensional, which is a highly computationally expensive, right? Now, it takes more time. Next, within the SVM, we are having the kernel SVM. The next one is called as kernel SVM. Now, what is meant by this kernel SVM? Kernel SVM is we are having different types of kernels are there. One is called as Gaussian RBF kernel. First one is called as RBF kernel. RBF means radial basis function, full form. Radial, R stands for radial, B stands for basis, F stands for function. Radial basis function. That is the first one, RBF kernel. What it is going to do is it is going to separate the data by normal distribution curve. So, for example, you are having data points like this. It will try to separate the data in this way. The curve, you can't draw the curve as per your choice. The curve is a fixed curve. What are the fixed curves we are having? Miss, one of the curve is bell curve. Okay, this is the first curve. One more curve is there. What is the curve? Can anyone tell me? Which we have discussed in the class. What are the different types of curves we have discussed in the class? One is bell curve, which we have discussed in the statistics. What is one more curve we have discussed? Huh? Yes, this is statistics. In the statistics, I have told you density curve. Density curve, which is for normal distribution, bell curve. Skewed curve, we no need to discuss because that is waste data. Anyways, it has to be converted to normal data. Now, what is the another curve? Can anyone? 2 days back only we have discussed sigmoid curve. Exactly. The second type of most important curve is sigmoid curve. Skewed curve and polynomial curve. These are common. For infinite, you can draw like this infinite number of curves. But which are standard curves means these are the two standard curves. One is Gaussian curve, that is normal distribution curve, and one is sigmoid curve. And third one, anyways, everyone knows which is the normal polynomial curve. As the degree increases, this is a quadratic curve, this is a cubic curve, this is a degree of 4, this is degree of 5, like this. Is that clear? Now, can anyone tell me what is the degree of this curve? What is the for what degree we have got this curve? Can anyone tell me for what degree? Huh? Please bit louder, please. 3. Yes, 3. Answer is 3. Because we are having the 2 bends. For quadratic line, we'll have 1 bend. For cubic curve, we'll have the 2 bends. First bend and second bend. Simple. If anyone draws like this and if they ask you, what is the degree of this one means? First bend, second bend, third bend, fourth bend. So it is a degree of 5. Count the number of bends plus 1 is the degree. Now, if you try one equation like this, x cube plus 4x square plus 5x plus 9. Substitute whatever the x values you want. Substitute whatever the x values and calculate the y values. Miss these equation values. Substitute any values of your choice. And draw the line plot. Automatically, you'll see with 2 bends only. 100% you'll see two bends will be there. Because this is a cubic line now, two bends will be there. Sir, if I take minus 4x square, still two bends will be there. Cubic, whenever the degree of 3 is there, automatically if you draw a curve, that curve should have two bends. If you want, you can try. Take any of cubic choice of your choice, anything, any curve of your choice. I mean, any equation of your choice. Try any equation of your choice. For example, you try with 4x square plus 9x minus 14. What is this equation? What is the degree of the equation? Is the 2. Now, how many bends you have to get? 1. Try whatever the x value you want. Take at least 10 x values of your choice, whatever the values you want. Calculate accordingly y. Substitute the x values in this, you'll get the y values. And you draw the line plot. Automatically, the line plot will be, you'll have one bend. Sir, x values can be negative and positive also, na? Yes, you can take whatever you want. If x values are negative and positive means you may have like this. If x values only positive means you may have like this. But bend will be only one. Okay, try whatever the x values you want. And apply the line plot. You know how to substitute the x values. You know how to get the y values. You know how to draw the line plot also using the matplotlib. And check, practice. And you will only understand easily. Is that clear, guys? So these are the different types of kernels. Now let us see the coding part. Now in the coding, the hyperparameters, two important hyperparameters will be there. Out of which first hyperparameter is called as kernel. So what are the different types of kernels we are having, miss? First hyperparameter. What are the hyperparameters of SVM? What are the hyperparameters of SVM? 1. What is the first hyperparameter, miss? Kernel. What are the different types of kernel we are having, miss? First one is linear. If you apply linear kernel, it is called as linear SVM. Linear SVM is also called as maximum margin classifier. Maximum margin classifier. Okay. Second one is called as poly. Means you are increasing to the higher degree. This is the second one. Third one is called as sigmoid. Sigmoid kernel. By using the sigmoid curve, you are going to separate the data points. Next one is RBF kernel. RBF kernel means you are going to use the normal distribution line. That is that curve, bell curve, and you are going to separate the data points. So these are the 4 different types of kernels which we are having. Linear, poly, sigmoid, and RBF. This is the first hyperparameter and this is the values. So in your param grid, if you take a param grid, in the param grid, what are the things you have to consider, miss? A dictionary. Within the dictionary, the key name should be the kernel and the list of values should be the first one is linear, followed by poly, followed by sigmoid, followed by RBF. So what it is going to do? It is going to apply 4 of them. It is going to apply 4 of them. It is going to apply 4 of them and it is going to identify which one is the best one. Out of all of them, which one is the best one? First, it will try with a linear, followed by poly, followed by sigmoid, followed by RBF. Everything it will going to try. And it will only identify which is the best. It will only do everything. Nothing max you no need to do. Whatever we have discussed for last 15 minutes, this is all the interview questions. Everything is an interview question. Whatever the theoretical part we are discussing is the interview questions. In the interview room, they will ask you how the SVM works. What is meant by maximum margin classifier? And what are the different types of kernels are available? Now, what is meant by kernel? Kernel means nothing but curve. What means different types of curves? What are the different types of curves are there? What are the different types of kernels they are asking? Means different types of curves they are asking. How you can how the polynomial kernel works? What is meant by mapping to a higher dimension? What are the disadvantages of SVM? All these are theoretical questions. For all these theoretical questions, first we have to understand the theory. Now, practical questions, we have to understand how to implement the project using the SVM. Okay. And second hyperparameter we are having is called as C. One more hyperparameter is available in the SVM is called as C. Now, what is meant by C? C means regularization parameter. Regularization parameter. Now, the strength of the regularization is inversely proportional to the C. As higher the C value you have, the more number of the higher the C value, the less number of support vectors it is going to select. The higher the C value, the more number of support vectors it is going to select. If you give a very low value of C, it will take more number of support vectors in order to separate the data points. Okay. If you give the higher the C, now it will take the less number of support vectors and it will separate the data points. Is that clear, guys? So let us see in the coding part, the same thing one by one, you'll understand automatically. Now, this is the data set where in this data set, I'm going to work on the mouse viral study data set. Means, so we are, whatever the recently we are having the COVID, right? So in the COVID example, so for example, the COVID, they have released the Covaxin and Covishield. These are the two medicines they have released into the market, whether it is a Covaxin or Covishield. Now, Covaxin or Covishield, before releasing into the market, they have to test. So on what they are going to test? Means initially they are going to test on the mouse. So first they are going to inject the whatever the coronavirus is there, they are going to inject that virus into the mouse, and later they are going to give the medicine to the mouse and they are going to check whether how it is working. And based on the reactions, they are going to change the medicines. Again and again, again and again, again and again, they are going to change the different mls and different things. Now, how many experiments they are going to do like that, miss? How many medicines they are going to change every time they are going to change, miss? They'll make a, whatever the medicine one, first medicine, they'll try with 10 different dosages. With only single medicine, they'll try with 10 dosages and they'll see the output and they'll write that one. Now they'll apply the machine learning on this and they'll remaining 90, they no need to do. Based on the sample, they will work for the population. Now what they will do next, they'll try with the two different medicines, combination of two different medicines. In the Covaxin, how many medicines has been included? Anyone knows? For example, one BP tablet is there, means in that BP tablet, only one medicine only will be there. No, right? Inside that, something also will be added. Right? For example, one of BP medicine, which generally my father will use, is called as Telma H. Okay, this is one of the medicine. Now in this medicine, Telma is the Telistran. Medicine name is Telistran, 40 mg, and H means hydrochloric acid. So it is a combination of both of them. Okay, this medicine is a combination of two medicines. And there are some other medicines are there where inside that one name, we are having inside that some percentage of 10 mg of one thing will be there, 0.2% of one thing will be there, 0.1% of something. Like this, they are going to add a combination. Now for every combination, they have to make a trial and error, miss. When they will do? When they have to inject, when they have to see the result. After injection, immediately they can't see the result now. They have to wait now. Once they inject into the rat COVID medicine, it has to give some reactions or it is giving some positive response, means at least it will take 4 to 5 days. The entire COVID it is working or not, to check that one, it will take 5 days. Whether the medicine is working or not. Means now in the COVID, during the COVID season, total with respect to 1 year, in that 1 year, how many rats they have applied and how much of things they have applied, means everything in the back end, machine learning only, they have used more. Sample experiments they have conducted. After doing the experiments, they have concluded with respect to this. So similarly, again, medicines, different combination of medicines they have applied. And whatever the design of experiments they have done, what are the experiments they have done, whatever the actual answers they have got, whether it is killing the virus or not killing the virus, answer will get right. And for remaining experiments, they have used the machine learning. Some experiments they have done manually, some experiments without doing also, they have concluded the answer. And if you remember, and if you open the Google also, CoShield or Covaxin, whatever the name you are interested, you type. And they're going to say, this CoShield is going to give with a 71% precision. They'll use the word called as 71 precision. Others may not understand what is meant by precision. We know, right? What is meant by precision? So who are affected with the really affected, and in that how many of them are cured? 71% who are really affected with COVID. For them, 71% of this, it is going to help. What is the meaning of 71%? It will help means what is the meaning of that? Remaining 29%, it will not help only, right? For remaining 29% of the people, it is not going to help. That is the meaning actually. But they'll not highlight that one. They'll highlight with respect to 71% precision. Precisely, it is able to predict, and precisely it is working. Okay. Who were infected with COVID or for antibodies, to increase with antibodies or something. And many people has taken with respect to CoShield or Covaxin medicines. I think most of the people has taken. Of course, I have not taken. I know the result now. I have not taken. I have just avoided, right? So because I have studied that one, and they have applied the inference statistics and whatever the things they have applied, I have analyzed everything, and finally I decided not to take, finally, based on that analysis. So just, okay, that is not required. But here, the thing is, they are applying with respect to machine learning. This project description I'm saying. Here I'm having the medicine 1 in terms of ml and medicine 2 in terms of ml, and whether it has killed the virus or not. Yes or no. This is the project. And you have to predict for a new medicine. If this much of amount, 1.269, 2.345, if I give, whether it will kill or whether it will not kill. Yes or no. This you have to predict. By observing this data, you have to predict with this. That is the project. Right? Now, so here we are having the data set where I have applied the EDA, and the scatter plot is like this. Now, X is equal to this one, Y is equal to this one. There is no need of treating of missing values, because in my data set, there is no missing values. No need of encoding, because no data with respect to that. Directly, I'm going to, with respect to X and Y and X train, Y train. Now, modeling. If you observe the modeling from sklearn.svm, I'm going to import the SVC. SVC means support vector classifier. Okay. And here I'm going to take the default model. If you don't write anything, miss, automatically it will take the by default linear. Kernel is equal to linear by default. So default model. First, I'm going to try with the default parameters. Default parameters means I'm not going to change anything. And I'm going to do the modeling, evaluation, and model selection. Now, what is meant by modeling? First, you have to import, save into a model, fit on X train, Y train. What is meant by prediction? Prediction means model.predict on X train, model.predict on the X test. If you use this one, model.predict on X train, model.predict on X test. This is called as prediction. Once prediction is completed, next one is evaluation. In the evaluation, what you have to evaluate? Train accuracy, test accuracy, followed by CV. Right? In the last class also, we have done the same now. First one is modeling, followed by predictions, followed by evaluation. Okay. So now I'm going to calculate the train accuracy, test accuracy, and CV, which I have got 100% directly. Why I have got 100% directly? Because it is able to separate by linear line, easily it is separating. Not even one data point is also misclassified. Easily it is separating. That is the reason I have got with respect to 100%. But if you give this data set and if you apply SVM, it will not give the 100%. Because linear SVM will not work. By default, it will take the linear. It will not give the good result. Okay. Now, but here I have got the 100%. Now, hyperparameter tuning. So already you have got 100%. Now, still why you are applying hyperparameter tuning means, for example, for this data set, I have got 100%. For example, if you don't get the 100%, in that case, what you have to do? For that, I'm showing this one also. So from sklearn.model selection, import grid set CV, and you are going to take SVC as the estimator, and param grid is equal to the C values and the kernel values. Kernel is equal to linear, RBF, sigmoid, and poly. And you are going to apply, and you are going to identify which is the best parameter. Miss C is equal to 0.01 with a kernel of linear. Substitute the same thing and rebuild the model. And once again, you are going to get 100% accuracy. Right? Now the same thing, now you apply on this data set. After the class, first you practice this one, whatever we have done. And now you apply on this data set. Right? Sir, want sir, in SVM, you have completed the coding as simple as in 2 minutes. Just observe here. After training, once the training is complete, means from the KNN model, just tell me what we have done in the XDS KNN model with default parameter. First, default modeling, 3 lines of code. Let me keep both of them side by side. Data pre-processing is common. Anyways, I'm not going to change the data pre-processing. Okay, I'm not going to change the data pre-processing. So here, first KNN with default parameters, SVM with default KNN default parameters, 3 lines of code. This is also 3 lines of code. Prediction, 2 lines of code. Prediction, 2 lines of code. Evaluation, first you have calculated train accuracy, test accuracy, followed by CV. How many lines of code you have written in this particular cell? Total 6 lines. 3 lines, 3 lines, 6 lines. Here, here what you have done? In 3 different cells you have taken. If I copy everything into a single cell, cut. If I copy everything into a single cell, what happens? And if I keep the heading as here itself, evaluation, stress, whatever we have done, I'm keeping everything in a single cell. Now tell me what is the difference you have observed between this one and this one? What is the difference? Only the first line is the difference. Import KNN, import SVM. Remaining everything is same only. Copy paste. I only have done right. Copy paste. I also will do copy paste only. I will also not do separately. Right? Initially, when I'm student, I used to do that one. Now my typing speed is very high, right? So automatically I can do without doing the copy paste also. If I do copy paste also, no problem. The same to same, whatever we have done in the XTS class. Instead of writing in 3 cells, I have written in the single cell only. That's it. And after that, what we have done here, applied the hyperparameter tuning. Applied the hyperparameter tuning. Tell me what is the difference between these two? Here estimator is equal to KNN. Here estimator is equal to SVC. Here the param grid is n neighbors and p value. Here n estimators are C and kernel. How I can apply this n neighbors concept here? This concept is entirely different. This concept is entirely different. Now, once this is completed, now I have got, after that, what I have done? Better with the whatever the best hyperparameters I have got. Again, I have applied the same thing I have done here also. Tell me what is the difference I have done? First line already anyways I have imported. I don't need to import once again. This one also you can delete. This one also you can delete because you already imported now. How many times you will import? One time only. You have to import every one time only. No need to import every time, right? So this is this one is predict on X train, Y train. Next test accuracy, train accuracy, and evaluation. Tell me what is the difference you have observed this one, yesterday's and today's one? Copy pasting only up and down lines, but everything are same only. That there 2 cells are there, here 1 cell only is there. That is the only difference, but everything is same only. Though I write in the 10 different cells, if I copy everything into single cell also, concept is same only. And after this, what I have done? Confusion matrix. If you're interested, you take the confusion matrix. Confusion matrix, anyways, you'll get the correct answer directly. Same to same. Is that clear? First, you are applying the default model. First cell is default model. In the default model, modeling, prediction, and evaluation, you are completing in a single cell. After that, hyperparameter tuning. You are taking the hyperparameter tuning in a single cell. Once the hyperparameter tuning is completed, next you are going to do the whatever the hyperparameter tuned values you have got, you are going to rebuild the model once again. Here you are going to rebuild the SVM with best hyperparameters, KNN model with best hyperparameters. 3 cells. First cell is default parameters. Second cell is with respect to hyperparameter tuning cell. Third one is rebuilding the model once again. Anything special is there? Is that clear? Coding part? I told that is the reason machine learning coding is dead easy. There will be no difference. You have to change only one line of code. That is import from sklearn.nibus. You have to use import sklearn.svm. Only this line will change. This line will change. Okay. And import SVs you have to import, and this one. Remaining everything is same. Predict on X time, predict on X test, calculate train accuracy, calculate test accuracy, calculate CV. Same story. Repeat, repeat, repeat. Tomorrow's class also same story. Day after tomorrow's class also same story. In the coding part. Okay. Data pre-processing we have to do irrespective of algorithm. In which case we have to do this one, which case we should not do this one. That is not dependent on the algorithm only. Data pre-processing entirely is irrespective of algorithm only. Only for KNN, scaling is mandatory. Scaling is mandatory. For that too for for KNN. For others, if you do also no problem. If you don't do also no problem. The answer will not change. If you want, you can try in SVM. With the scaling, you'll get the same answer. Without scaling also, you'll get the same answer. Not even minute difference also will be there. If you want, you can check. Apply whatever the data set you want. Because the SVM is not depending on the distance formula. Na? If it is not applying on the distance formula, anything is same for it. Is that clear, guys? That's it. That is the end of the session. And we'll continue in the tomorrow's class. And I'm going to upload the notes. Tomorrow's class is more important. If you miss tomorrow's class, don't come to the class for next 5 days. Because tomorrow's class is interlinked for next 5 days. And most important concept is called as decision trees. And that is the one of the most important algorithm, which is